RCAS is the University of Sheffield's entry into the IMechE Railway Challenge competition. We're a team of undergraduate students with PhD supervisors and an academic supervisor. We design, build and manufacture our own 5th scale locomotive. The Railway Challenge competition is an annual competition hosted by the IMechE at Stapleford Miniature Railway. There's teams from across the world that enter. We all enter our own 5th scale locomotive, compete in a series of track-based and paper-based challenges, and at the end of the weekend there's an overall winner and you also win individual challenges.
One of the key aspects of the Railway Challenge is the Ride Comfort Challenge, which looks to assess the performance of the locomotive suspension system to isolate vibrations from the track. Historically, the Ride Comfort Challenge has been one of RCAS's weaker challenges, largely due to a lack of understanding of the dynamic behaviour of our locomotive. So we've been looking to do some more dynamic testing of our loco to improve our understanding of the suspension system and hopefully inform future designs to improve the system. We decided to vary 3 parameters during our testing. These were the mass of the chassis, the primary suspension and the pressure in the air bellows, which make up our secondary suspension. Our primary suspension consists of 2 springs between the axle box and the bogie frame. So we varied this by locking the springs, which is something we do when we're transporting the locomotive, which increases their stiffness. Our secondary suspension consists of 4 air bellows on each bogie that go between the bogie frame and the chassis itself. We change their stiffness by increasing and decreasing the pressure in them to investigate how we can change that, moving to a different air bellow system for our new locomotive. We increased the mass of our chassis by loading old base plates and bogie frames onto either side of the chassis to keep the mass evenly distributed. This is really helpful for us because we can investigate how changing the mass changes the system, especially as we're moving to a longer chassis that will then be ride-on for next year's competition as well.
The main points that we put the sensors were firstly on the axle boxes to get the rough track input, and then above the primary suspension to just isolate the primary suspension, and then finally on the underside of the chassis to get the interaction between the primary suspension and the secondary suspension for the input data. And then we also had some other ones on the front, the rear and either side of the loco to get the rolling and the pitching to see if it had more side-to-side motion or more front and back and subsequent. And then finally we had one in the middle of the locomotive just under the chassis. This was to mimic where we placed the accelerometer for competition to see if this was the best place that we could put it to minimise the ride input data.
The unique challenge with mounting the rail to the shaker table is that usually rails are designed to damp the vibrations of the locomotive, and since we didn't want any of that damping and all the signals from the shaker table go directly into the loco, we used a series of metal brackets to mount the rail directly onto the table. Another challenge was that there was actually a height difference between the table and the rest of the shop floor, so we used some of our other track with sleepers to bridge that gap and roll the loco on to the table. So another challenge we faced was making sure the loco stayed on the table once it was on, so we used some ratchet straps around the axles in order to keep the loco where it is and also not compress any of the suspension systems at the same time.
We had 2 different input streams that we fed into the mast. The first was track input data that we measured down at Queen's Park in Chesterfield when we had the locomotive out there for testing earlier in the year. And the second was a sine sweep up from 0 to 70 Hertz, which I think we find is going to be a lot more useful to analyse how the locomotive dynamics are changing over that frequency range.
We looked at the data we got from the LVV, and we saw that we had a massive excitation peak in a really uncomfortable region for humans. And we aimed to bring this peak down by implementing damping in parallel to our air bellows. We'd also like to move this peak. To do this, we can alter our chassis mass and our air bellow stiffness. Naturally, the chassis is going to get heavier this year because we're going ride-on. And with this combined with reducing our air bellow stiffness, we'll move that peak into a much more comfortable region. We looked at the roll characteristics of the locomotive as well, and this confirmed that altering our air bellow configuration would also improve ride comfort performance.
Testing at the LVV enabled us to have more sensors on board the locomotive and to have a more accurate control over the vibrations we were inputting through our suspension. From this data, we were able to interpret what changes we wanted to make to the locomotive to improve our ride-on comfort. This allowed us to carry out a more detailed investigation into the functionality of our loco's suspension. This will ensure the changes we've made to the locomotive have improved our dynamics.
Doing this testing at the LVV was really helpful for me because I'm going into a graduate job in research and development next year. So it's really great to be able to see exactly the capabilities of a research centre like this and how I might be able to use them in the future with the connections that I've gained, and also figuring out what sort of data they need from us to run some testing and what sort of data they can give back.
I think the main benefit to me was that it's been cool to be able to do a piece of research in a professional environment that as an undergraduate you don't really get to do, and to be able to see how that kind of operates and be hands-on with undertaking all the necessary steps in procurement and then the setup before you even actually get to the testing has been really interesting for me.